Welcome to AMR Physics. I am Raju, NCERT 12th Physics. We are solving the numerical problems given in Chapter 5, Magnetism and Matter. In this video, we are going to see how to solve the book back problem 5.2. The problem is a short bar magnet of magnetic moment M is equal to 0.32 Joule per Tesla is placed in a uniform magnetic field of 0.15 Tesla. If the bar is free to rotate in the plane of the field, which orientation would correspond to its A. Stable and B. Unstable equilibrium? What is the potential energy of the magnet in each case? This is a given problem. In this problem, let us see what are the numerical data given. Magnetic moment of the bar magnet is given, which is 0.32 Joule per Tesla. Magnetic field is 0.15 Tesla. The bar magnet is free to rotate in the field. What is asked? We have to find the orientation correspond to stable and unstable equilibrium. That is, we have to find the angle between the magnetic moment and magnetic field correspond to stable as well as unstable equilibrium. Also, we have to find the potential energy in these two cases. Now, let us see how to solve this problem. There are two questions to be answered in this problem. First is, we have to find the orientation for stable and unstable equilibrium. Second, we have to find the potential energy in each case. Now, let us consider the first question, orientation for stable and unstable equilibrium. The magnetic potential energy is given by the relation U suffix m is equal to minus m vector dot b vector. This is a vector dot product. Therefore, this can be written as U suffix m is equal to minus m b cos theta. From this relation, we can understand that the value of m depends on theta if m and b are not changing. So, if theta is equal to 0, if theta is equal to 0 degree, then um is equal to minus mb. This is the minimum possible potential energy. So, the potential energy is minimum if theta is equal to 0 degree. The potential energy is minimum. This is the minimum possible value. If the potential energy is minimum, then the bar magnet is in stable equilibrium. Bar magnet is in stable equilibrium. Here, theta is the angle between m and b. Theta is equal to 0 means m and b are parallel. Therefore, the orientation corresponds to stable equilibrium is theta is equal to 0 degree or m and b are parallel. If theta is equal to 0, that is, if m and b are parallel, then that is the orientation for the bar magnet to be in stable equilibrium. So, this is the answer for the first one. Similarly, if theta is equal to 180 degree, then um is equal to U suffix m is equal to, this is a magnetic potential energy, minus m b cos 180 degree. This is equal to minus mb cos 180 is minus 1. This is equal to plus mb. The potential energy is maximum. This is the maximum value of the potential energy. For a given value of m and b, the potential energy is maximum if theta is equal to 180 degree. If the potential energy is maximum, then bar magnet is in unstable equilibrium. So, we can write the answer as orientation for unstable equilibrium is theta is equal to 180 degree, or we can say that M and B are anti-parallel. If theta is equal to 180 degree, then the bar magnet is in unstable equilibrium. That means if M and B are anti-parallel, this is the orientation for the unstable equilibrium. Now let us answer the second question. What is the second question? The second question is we have to find the potential energy in each case. That is, we have to find the potential energy correspond to stable equilibrium and unstable equilibrium. We have already discussed that U suffix M is equal to minus MB cos theta. If theta is equal to 0, then the potential energy is minimum. The system is in the stable configuration. So, for stable equilibrium, theta should be equal to 0 degree. M and B are given. Magnetic moment M is equal to 0.32 Joule per Tesla. Magnetic field B is also given in the problem, which is equal to 0.15 Tesla. Therefore, we can find the potential energy for the stable configuration. The potential energy for stable equilibrium is equal to minus, what is M? M is 0.32. What is B? It is 0.15. And what is the value of theta for stable equilibrium? It is 0 degree. Cos 0 is 1. Therefore, UM is equal to minus 0.048, and the unit of potential energy is Joule. So this is the potential energy for stable equilibrium. Similarly, we can find the potential energy for unstable equilibrium. For unstable equilibrium, theta is equal to 180 degree. We know the value of M and B. Therefore, UM is equal to minus 0.32 into 0.15 into cos 180 degree. This is equal to minus 0.32 into 0.15 cos 180 is minus 1. So this is equal to minus of minus plus. We will get 0.32 into 0.15 is equal to 0.048. This is a potential energy for unstable equilibrium. Unit of potential energy is Joule. This is the answer to the second question. In this problem, there are two questions. One is we have to find the orientation for stable and unstable equilibrium, and second is we have to find the potential energy for stable and unstable equilibrium. We have answered these two questions. I think you can able to understand this. If you find this video is useful, please subscribe the channel, share it to your friends. If you have any doubts, comment below. Thank you for watching this video.